So next topic, force between two parallel current carrying conductors. So we have to find out force between two parallel current carrying conductors. That is a mutual force between two conductors. Here there is no external magnetic field, right? So suppose we have AB and CD are two conductors, both of them carrying same current I and equal length L. Both the conductors are carrying same current. If we consider different current, then we can write I1, I2 also, but length is same. Suppose let I1 is the current through AB and I2 current through CD conductor. L is AB, CD, same length. Two conductors have equal lengths. Now, how they will experience mutual force? The point is that when a conductor is placed within a magnetic field, it experiences some force. And another thing is that when a conductor carries current, then it produces magnetic field. Okay. So two important points. Number one, the points to be noted. Number one, current carrying conductors produces magnetic field. So we can find out the strength of the magnetic field. So both of the current, suppose R is the distance between them. They are placed at a distance R apart. R is separated by R is a distance between two conductors. Because they are parallel, so at all points R will be same. So first point to be noted, important points. What are the points? Main points is that current carrying conductors produce magnetic field. So in this case, both the current carrying conductors will produce magnetic field, right? Second point is that when current carrying conductor is placed in a magnetic field, it experiences force. Another important point is that when current carrying conductor is placed in a magnetic field, it experiences a force. So both the important principles we'll be using here to find a force. The force experienced by the conductor can be calculated. The magnetic field produced by the conductor can be calculated. Both of them can be calculated. So we have already calculated the magnetic field produced by a straight current carrying conductor. Okay. So what will be the magnetic field produced by AB? The magnetic field produced due to CD at point P is given by. So if we consider this is the current carrying conductor and it produces magnetic field at a particular point, suppose at point P, okay, at this point, at point P at a distance R from the conductor. So by definition, suppose it is B1 as produced by this conductor, B2 suppose, B2 or BCD, you can write CD also, no problem. BCD is a magnetic field, magnitude of magnetic field produced by CD at point P, which is given by definition mu naught I2, because I2 current is flowing through this, mu naught I2 twice pi R. This is by definition BCD. The magnetic field produced by CD at point P at a distance R is given by mu naught I2. I2 is the current flowing through CD. Mu naught I2 twice pi R. This is the magnitude. Already it has been calculated due to a straight line, a straight current carrying conductor when I2 is the current flowing through the conductor. Okay. Now point is that this magnetic field BCD, this magnetic field, the value of this magnetic field at a distance R from this conductor will be same at all points on AB. So this is at point P, the same value will be obtained at all points over AB because these are the parallel. At each and every point, you will get the same value of magnetic field due to this one, right? What does it mean? It means that the AB conductor is placed in a magnetic field according to this principle. When current carrying conductor is placed in a magnetic field, it experiences a force. Definitely, this current carrying conductor will experience some force due to this magnetic field as produced by CD. Right? So we'll use now second principle, that is second condition. Therefore, the force experienced by AB, the conductor AB, is what will be the force? Already we have got one formula that a force experienced by a current carrying conductor can be given by the formula I L cross B. Okay, it's I L cross B is the force already we have calculated. So say this is the force experienced by AB. Force AB, the magnitude of force. So I L B sine theta, because theta is 90 degree here. Okay, so these are perpendicular to each other. L and B. The magnetic field produced here will be perpendicular direction to this conductor. So L and B will be perpendicular. This is why the theta sine theta will be equal to 1. This maximum force will be experienced by this conductor AB. Now, whether it will be I, it will not be I. So because the current, this conductor carries a current I1. Okay, so we have to write it I1. I1, L is same, and in place of B, we have to write B, CD. Then putting the value of B, CD, what we will get? I1, L, mu naught, I2, twice by R, rewriting this mu naught I1, I2, twice by R into L, right? So this expression gives a net force. So if you find out the force per unit length, then you have to find out like this: F AB divided by L divided by L is equal to mu naught I1 I2 twice pi R. So this is the force per unit length expression. In the same way, we can find out the force experienced by another conductor CD will be also same. Same value will get force CD. The length is also same, is equal mu naught I1 I2. Same value will obtain. The force experienced by another conductor will be also same. Now, question may arise in which direction the force will act. If direction of force, in which direction they will act. If I1 and I2 are same direction, if I1 and I2 are having same direction, then force is attractive. That is, both the conductors will attract each other if the two currents flows in the same direction. If I1 and I2 are opposite, then there will be repulsive force. There will be repulsive force. That is, if the direction of I1 and I2 are opposite to each other, then both the conductor will repel each other, right? So in this way, we can calculate the force, the mutual force between two current carrying conductor if they are parallel to each other. And let us see one problem. Question: two straight wires 20 centimeter long, 20 centimeter long, separated by 10 centimeter, 10 centimeter, if they carry currents 20 ampere and 30 ampere respectively, what will be the force between them, between the conductors, So we have to find out the mutual force between them. The force may be attractive or may be repulsive. It does not matter. Just we have to find out the value of force acting in between them. So what formula we'll have to use? We'll have to use the formula the force per unit length is given by F by L. Just we are writing F. Okay, mu I1 I2 twice pi R. So we have to put the values, all the values. The value of mu naught, as you know, the value of mu naught is equal 4 × 10⁻⁻⁷, right? And 20. Only thing is that R should be R is given here. R is 10 centimeter. Okay, so R is 10 centimeter. It should be converted into meter. So it will be equal to 0.1 meter. R is 0.1 meter. So the value of mu naught is equal to 4 pi into 10⁻⁻⁷. I1 is equal to 20. I2 is equal to 30. Twice pi 0.1. So it will be cancelled 2. Okay. So we have to solve it, and we will get the value as 2.4, 1.2 into 10⁻⁻3. The answer will be 1.4 into 10⁻⁻3 Newton meter. Since we are calculating force per unit length, therefore it is Newton per meter. So if you want to find out net force, then you will have to multiply it by 0.2, because the length is given as 20 centimeter length of the wire. So if you want to find the net force experienced by each conductor, then you will have to find out F is equal the net force 1.4 into 10⁻⁻3 into 0.2, because this is L, the value of L. Okay. To 8 into 10⁻⁻5 Newton. 28 into 10 to the power minus 5. It should be 1.2. 1.2 into 10 to the power minus 3 Newton per meter. If it is 1.2, then it will be 24. 24 into 10 to the power minus 5 Newton is the answer. The net force experienced by each conductor. Okay.